Hello everyone, welcome to Pre-Algebra with Miss Betsy. Today we are going to begin a review of fractions and equivalent fractions. Now I'm using as my text Pre-Algebra for Christian Schools, published by Bob Jones University Press. If you're tracking along with us, we are in the first edition of Bob Jones Pre-Algebra. We are in section 6.1, which is page 177. It's called Fractions and Equivalent Fractions. But of course, before we get started, I've got a question for you. What kind of coat can you put on only when it's wet? Yeah, most of you knew that. It's a coat of paint, because it definitely doesn't work to put a coat of paint on when it's dry. So let's go ahead and see what we have here today about fractions. And you will remember and recognize that when you have a symbol that looks like this, 1/2, that's called a fraction, okay? And we have some specific terminology. The top number of a fraction is called the numerator. The bottom number of a fraction is called the denominator. This is vocabulary that you absolutely have to understand. Now in general, the way that you write a fraction, if we wanted to use like just an algebraic general expression, this is how you write a fraction. It's a over b, where b is different from 0, and a and b are integers. Some form of a whole number. You don't want to have 1/2 divided by 2/3, even though you can have that. It's what they call a complex fraction. But in general, we're going to recognize a fraction looking something like this. We have to put this little qualifier in here that tells us b, or the denominator, can't be equal to 0, because we remember from our division rules that to divide something into 0 groups is meaningless. So this is what we call a fraction. And what we do is fractions are used to describe a part of a whole. So let's say that we have these 3 circles here. I'm going to cut one of them like this. I'm going to cut another one into 4 pieces. I'm going to cut another one of these circles, try to at least, into 6 pieces. And we're going to give me grace here, and we're going to assume that these are even, these 4 pieces are all the same size, and these 6 pieces here are all the same size. Now if we were to go ahead and shade in one of these halves right here, this can be written as described as a fraction where the denominator represents how many pieces one whole thing is cut into, one whole circle is cut into. The numerator represents how many of those pieces we're counting, or in this case, how many of those pieces are actually being shaded. So if I shaded 2 of these, I would write this fraction as 2/4, because the whole object has been cut into 4 pieces, and I've shaded 2 of them, or I've counted 2 of them. Likewise, over here, I have cut this one whole object up into 6 pieces, and I have counted 3 of them. Now, if these circles were the same size and everything was measured exactly correctly, you would see that even though we've cut them into different pieces, I still have represented here 1/2 of the circle. It's like the lame joke I told in class on Friday. Blonde went in and ordered a pizza, and the guy said, "Do you want me to cut it into 2 pieces or 4 pieces?" So the blonde thinks for a minute. She says, I'll just go ahead and cut it into 2 pieces. I'm not very hungry today. Yeah, that was lame. Half a pizza is half a pizza is half a pizza, regardless of how many pieces you've cut it into. So what we see here is that 1/2 is the same as 2/4, is the same as 3/6. So what we have here, these are called equivalent fractions. Now equivalent fractions is another bit of vocabulary that you simply must know. These are equivalent fractions. Equivalent fractions are never going to look the same when they are written using numbers, using digits in fractional form. 1/2 doesn't look the same as 2/4, doesn't look the same as 3/6, but they're equivalent because they represent the same amount. And you see that here very clearly with these pictures. But all 3 of these represent half of a circle, even though the fractions themselves look very different. That's what they call equivalent fractions. And what you will learn, what you'll remember, is the way that you find equivalent fractions is by multiplying or dividing the numerator and the denominator by the same number. So let's go ahead and look at some examples here. Say that we have 2/3, which can also be, which is the same as 2/3, whoa, I have a hard time with that, 2/3 times 3, and let's look at this one here. It's a little bit too early in the morning. Instead of writing 21, I reversed the digits and wrote 12. 21 divided by 3. So I said that you could find equivalent fractions by multiplying or dividing by the same number. We started here with 2/3. I multiplied both the numerator and denominator by 3. When I did that, I ended up with 6/9. We can do this because when you multiply any number, any expression by 1, you don't change its value. And any number divided by itself, here, 3 divided by 3, that's equal to 1. So here we ended up with 2/3 and 6/9. These are examples of equivalent fractions. And we arrived at those equivalent fractions by multiplying both the numerator and the denominator by the same value. Multiply both the numerator and the denominator by 3. Now here we have 15 divided by 21, and we divided the numerator and the denominator by 3 to end up with 5/7. These are also equivalent fractions, because when you multiply or divide the numerator and the denominator by the same number, your fraction looks different, but it represents the same number. What we've actually done here, this fraction has been reduced to lowest terms. That means there's no factor of the numerator that also occurs in the denominator. This fraction here, clearly though, is not reduced to lowest terms because you have the same factor in both the numerator and the denominator of 3. So now we're going to go ahead and see how can we determine if 2 fractions are equivalent. right here, we know that 15/21 is the same as 5/7 because we actually divided both the numerator and the denominator by 3. So we've already illustrated that, but there's a way that you can also determine whether or not, identify whether or not two fractions are equivalent, and that's by using something that they call cross products. But let's go ahead, before I talk about cross products, let me look at example number 1 here. This says, replace the variable to write an equivalent fraction. So here's our first example. Example 1, part A. This tells us 5/8 is equal to x over 24. So what we have to do is figure out, remember we said if we multiply the numerator and denominator by the same value, we have equivalent fractions. Well, they've already multiplied the denominator by something because we've ended up with the 24. So we say, okay, 8 times what is going to give me 24? 8 times 3 is 24. We have to multiply the numerator and the denominator by the same number. We multiply the denominator by 3, means we have to multiply the numerator by 3 as well. So our equivalent fraction here, 5/8, is equivalent to 15/24, and we can say that x here would have to be equal to 15. Now, if we wanted to write this equivalent fraction, 15/20 is equal to y over 4. is equal to y over 4. We have to figure out what value we need for y here so that we have an equivalent fraction. We've already done something to this 20. So that we can arrive at 4. How do you get 4 if you begin with 20? Well, you divide by 5. 20 divided by 5. Since we divided the numerator by 5, we also have to divide the denominator by 5, and we have an equivalent fraction. If we say here that y is equal to 3, then we have an equivalent fraction. Now, this is an illustration of how you have to know your math facts. Multiplication and division makes your job so much easier. But let's say, okay, I don't know what I have to divide by. Well, you can always think 20 divided by 4 is going to give me what? But you still have to know that basic math fact that tells us 5 times 4 is 20. 20 divided by 4 is 5. 20 divided by 5 is 4. And there's nothing I can do to help you with that if you haven't learned your multiplication and division facts. So now's your very last good opportunity to make sure you've got those all nailed down where you can automatically look and figure out the missing factor. Okay? Now, back to cross products. I was going to say cross products. This is very important. Write this in notes. If the cross products of fractions are equal, the fractions are equivalent. The fractions themselves are equivalent. So we just demonstrated that 15/20 can be written as an equivalent fraction of 3/4. But what are cross products? The cross products are what result when you multiply together opposite factors. If those cross products are the same, then you know that the fractions are equivalent. We're always going to start on the left-hand side with the product from the numerator. So let's see if it's true that these two fractions truly are equivalent. We just showed where we could divide both the numerator and the denominator by 5 to end up with 3/4. We're verifying this now by saying that our cross product, beginning with the numerator, 15 times 4 is 60. And our cross product with the denominator here, 20 times 3, is also equal to 60. So yes, these two different looking fractions have the same value. They are equivalent because their cross products are the same. So it's essential that you understand that, okay? Let's go ahead and look at page 177 in our book. Use cross products to decide whether 7/9 and 29/36 are equivalent. 7/9 and 29/36 are equivalent. 7/9, 29/36. Are those two equivalent? Well, let's check our cross products. 7 times 36, is that equal to 9 times 29? This is where you want to show your work, show your scratch on the right-hand side of the paper. 36 times 7, 7 6s are 42, plus 1, 7 3s are 21, plus 4 is 252. Now, what do we have? 9 times 29. Well, obviously they're not going to be the same because 9 times 9 is 81. Carry 8. 2 9s are 18 plus 8 is 6. 261 is not equal to 252. The fractions are not equivalent. Because the cross products are not equal, the fractions are not equivalent. And you could perhaps have easily seen this already by thinking, okay, 9 times what gives me 36? They've multiplied 9 by 4 to arrive at 36. Well, you'd have to say 7 times 4. 7 times 4 does not equal 29. 7 times 4 is 28. But we demonstrated that these truly are not equivalent by showing that the cross products are not equal. Okay? Now, what are you going to do if you wanted to rename a fraction in lowest terms? And what does it mean to rename a fraction in lowest terms? Well, what that means is that there are no factors in common in the numerator and the denominator. So let's look at this first one. 12/18. And how are you going to rename a fraction in lowest terms? There's a foolproof method here, and this is what they tell you. You divide the numerator and denominator by the GCF. What is the GCF? What is the greatest common factor? Well, the greatest common factor is the largest number that is a factor of both the numerator and the denominator. Now you can use a couple of different techniques here to help you make sure that you reduce your fraction to lowest terms. You can think, okay, well I know both of these numbers here are even, so I can divide by 2. If I divide both of these numbers by 2, I'm going to have 6/9, but then I still have to divide some more. Let's say, what's the greatest common factor of 12 and 18? Well, 12 is equal to 2 times 6. 18 is equal to 3 times 6. This is just some intuitive things that you might understand. I'm going to show you a method just in a second, foolproof way of reducing to lowest terms. But here, if you divide 12 by 6 and 18 by 6, 18, not 12, 18 divided by 6, 12 divided by 6 is 2, 18 divided by 6 is 3. So we have divided both the numerator and the denominator by the greatest common factor, the largest number that divides into each numerator and denominator. We've ended up with 2/3. This is a fraction that is reduced to lowest terms. There are no common factors here because 2 is a prime number, 3 is a prime number. There's nothing else here that we can cancel common factors in the numerator and the denominator. And another way that you can do this is to factor the numerator and the denominator into prime factors and cancel the common factors. So if we have 12 and 18, by now you may or may not know that 12 factors into 2 times 3 times 3. Prime factors, 2 times 2 times 3. 18 is 2 times 3 times 3. How do you find out the prime factorization of a number? Well, you can use factor trees. 12. What are 2 factors that when you multiply them together you get 12? Well, you might say 3 and 4. Is 3 a prime number? Yes, it is, so you circle that. Is 4 a prime number? No. Well, how can I multiply that? What 2 numbers can I do? Well, that's 2 and 2. Both of these are prime. So when you're using this factor tree, you continue this process. Go back and watch the video about doing prime factorization if you forget how to do it. And you realize that all of these factors here, all of these circled numbers are prime numbers, so we're going to write those as a product of prime numbers beginning from the least, going to the greatest. 2 times 2 times 3. 2 times 2 is 4 times 3 is 12. So that's the prime factorization of 12. You can also prime factor 18 by using the factor tree or by using upside down division. 2 goes into 18 9 times, 3 goes into 9 3 times. When you have all of your outer numbers being prime numbers, your factorization is complete. You always want to begin, when you're doing an upside down division, begin with your lowest prime number, use it as a factor as many times as possible. Then you replace this 18 for the product of primes that we have indicated here. 2 times 3 times 3. Then we learned that canceling common factors means that if you have the same number in the numerator as you do in the denominator, you can cancel those out because that's just the same as multiplying by 1. 2 divided by 2 is 1. 3 divided by 3 is 1. Then you rewrite this fraction where you are only showing the factors that are remaining, which is 2/3. So whether you look at this and divide both the numerator and denominator by 6, or you write the numerator and the denominator in prime factored form and cancel common factors, this is what it looks like when you have a fraction that is in lowest terms. You always need to reduce your fractions to lowest terms. These are two different ways that you can do that. And that's all that we're talking about in section 6.1, and I will see you next time.